Let's get to it.
I'm going to ask everyone to please mute, or I'll just go ahead and mute everyone.
There's a lot of slides, but they go pretty quickly. And I've already put the PDF set of slides in the chat for anybody who wants them for detail for later. Okay, here we go. This is more a toolbox for dialogue. So it's freshwater in development and what you might need to engage in dialogue. Let's see. Three or four broad sections. Introduction is more natural sciences, natural and social sciences, management, where we've come historically, by approaches and discussion. If we're going to have a dialogue or a type of communication, we ought to be aware of what kind we're going to have, a cooperative one or a competitive one. Is it two-way or one-way? And so for a discourse, you might write a paper or a book. Dialogue, you're going to exchange information and build relationships. And you might listen to an op-ed or something for someone who making an emotional appeal. And whether you want to get into a debate or not is up to you, but you should at least be aware of when you're being drawn into one.
Mark, I think you're sharing your desktop, and you may have to.
That would make sense. So
yeah.
Thanks for that. Well, if I were Jim Carrey, I'd make that sound of a recorder going backwards, you know. Let's try it again. Are we good? We are good.
There we go.
All right, let's back that up. All right. What kind of discussion you're going to be into? It's a two-way discussion, a one-way. Is it dialogue? Is it discourse? And if you're getting pulled into a debate, you should be aware of that is happening. Water is extremely contextual. It's sort of like going to a train station at the information desk in Switzerland, where there are 4 languages. And I watched this happen one time where there was a woman in the booth, and people would come up and speak a certain language, and she would just flip from one language to the other very easily. So that's sort of like water. You've got to know which language you're speaking and where you are. If I can point over here, this is what we're all used to: service delivery. We get water delivered to our house. We get wastewater pulled away, and that's a developed country context. If you are, it's a different process in a developing country. They may take your wastewater away, but they're going to put it in buckets and put it in a truck. Okay, household, community, watershed, basin, country. Going this way, you get these are different services: sanitation, domestic water industry, agriculture, and ecosystems. We don't usually do agricultural water as a service delivery at home, but it does happen using potable water. Of major interest, I think, for our purposes for dialogue, is in the resource management level. There are 2 main discussions or dialogues. One would be IWRM, and the other one, and my screen is blocking. And this is, I believe this is going to say source to sea, where they're looking at wastewater going into the ocean, where integrated water resource management is water only, and people having dialogues about who's going to use what water. From a research perspective, you would say for water, you've got the world, you've got international development, You've got water resources development. But if you're speaking of something like climate, there is no developing world. It's a global context. So whenever I've gone to meetings about water, and people will listen to a question and their first response is, what context are you talking about? Because it makes a difference in how to interpret the question and how to give an answer. This is a systems approach overview. I'll break it down a little. These are a couple of variables: bigger the population, bigger the economic growth, bigger the consumption. Consumption means more resources and more wastes. And on this slide, I'm just pointing towards ecosystem services. You got production, what you harvest, your lumber, your fish. Regulation, it'll regulate floods and drought. It'll also regulate your water quality. It's a life support system where it keeps the soils alive, keeps everything alive, and gives us oxygen. And then the cultural practices, beliefs, and beauty. It's similar, not unlike the 3 pillars of sustainable development, where Will Stephan is saying he would like to remove the word resource from the whole discussion and start thinking in terms of a One Earth life support system. Okay, so going back to this, we have these couple of You've got obsolescence of materials, spoilage of food. It takes you produce waste when you're producing raw materials, but the main takeaway from here is we've got energy, food, water, and ecosystems. So a systems view will automatically imply or point to the water, energy, food, and ecosystems nexus. That's if everything's in balance. We've all heard of Bobby Orr. Here's the hockey stick he invented, and it has this shape here, the famous hockey stick graph back in 1997. Mann, Bradley, and Hughes from the University of Massachusetts in Amherst went back about 500 years, and they made this showed a deviation of temperatures at ground level. And it was published in the third assessment report of the IPCC, and became famous for debate in the hockey stick graph. Jump ahead to 2021, the IPCC has since applied this. This was all just North America. Now this is to the whole world, and it's going back 100,000 years, and they're coming up with the same conclusion. A hockey stick is all about this level variable, if you will, non-move. It's pretty much constant, not a variable. All of a sudden, there's a big change. But you got massive land animals, and animals' extinction rate is the same thing. But one is drawn one way, one is drawn the other way. These are both hockey stick graphs, but one is meant to point in the right direction. These are Earth system trends. They're all kind of showing the hockey stick graph. They all mirror it. 1750 was the beginning of the Industrial Revolution, but 1950 to present is what's known as the Great Acceleration, and this is where we see the blade of the hockey stick. Okay, social economic trends. You got water use, energy use, fertilizers, per population. They're all going up like a hockey stick. The previous one, this is a global assessment. Will Stephan broke these down into areas just to show some inequities, if you will. For example, population, the developed countries have very slow rate of population growth, but the countries in transition and developing countries are a lot faster. That's where most of our growth has come in the last 50 years. This is historic. This is not protracted. And then in contrast, GDP has been mostly with the developing countries. and very little GDP growth in the developing countries. Water use has gone up, and fertilizer. Again, the developed countries are pretty much stable, whereas water use and fertilizer consumption, that is food, is mostly advanced in the developing countries, developing and in transition countries. If you don't think we're impacting the environment, 96% of all land, land animals is either farms or people, only 4% are wild. 70% of all chickens are on farms. This is what Will Stephan was leading up to. He was making the case that we've left the Holocene and gone to the Anthropocene. This represents the Ice Age. We went down to about 600 people. We almost went extinct. And about 12,000 years ago, we came into this nice stable area known as the Holocene, where most of our history lies. And these limits to growth have pushed us, have destabilized us from the Holocene and have moved us to this area. These are the planetary thresholds he's talking about. And what we're trying to do is use an Earth system stewardship to push us back over to Holocene-like conditions, which would be stabilized Earth. If we don't, he calls this we're going to a hothouse Earth. Okay, and this is the Stephan and others, which we'll get, yeah, can't think of his name right now. Johan, they came up with the limits to growth chart. And what I want to point out, well, first of all, Stephan is saying that these three, climate change, biosphere integrity, and novel entities like chemical pollutions, these are the core boundaries because any one of them independently could represent an existential threat. And this is the original 2009 article, and you've got to look at what are the proposed boundaries, what's the current status, and what was the pre-industrial value. And if you look at water, it's saying consumption of fresh water by humans per year. And these are proposed boundaries, but I think they were kind of throwing darts at the time because it doesn't make a lot of sense. If you look at water, freshwater use, water is not destructible, it's renewable. It's more about its availability and its quality. So it's not really consumed, and there's another way to look at it, which we'll get to in a second. Let's see, Gleason also looked at the limit for water and said, well, there's a lot more going on here. We've got surface water, groundwater, soil moisture, frozen water, atmospheric water, and we've got different functions going on. So there's a lot going on here that is not represented in this limits to growth wheel or chart. So he made all these relationships about what water is other than functions other than what humans consume. And then Zipper built upon Gleason and took this moisture in the soil, atmospheric water, surface water, frozen water, groundwater, and said, how do we apply the global limits to local areas using fair share approach and local conditions? And this is something that IPCC has not been able to do for climate. They've aggregated values to global data, but they are not able to extrapolate that to local areas. This is an attempt at that. I'm not sure if it's successful. And then Kate Rayworth said, well, wait a minute, that doesn't represent the social needs that we have in addition to the environmental limits. She's saying two things. First, we have to consider the needs of people and not just the environment. This area right here is the have-nots. This is your wanting area, and this is your limit. But this is a double statement that she's making. She's saying you've got to take care of people as well as the environment, which is a statement of sustainability. But you've also got to live within limits. She's intentionally saying you've got to live within the environmental limits. So it's a step towards anti-consumerism, if you will, or moderation, a step towards moderation. And she's saying you can't always get what you want. Okay, so the same authors who came out with this chart, Rockstrom, and Will Steffen and others, just earlier this year, they have revised this chart. They've taken water and they've changed it to green water and blue water, which we'll get to in a minute. But just to give some legitimacy, we're going back to from the 2009 original chart to this year. They are changing water, how we look at water. Alan Falkenmark and Rockstrom did some work on blue-green water, and here she is updating something that she did earlier, updating in 2020. But what I want to point out here is she's already, well, this has to do with socio-ecological systems, and she's trying to conceptualize how society meets with the different functions of water. But note also she's using green and blue water already. Okay, this is the Falkenmark and Rockstrom original publication. Basically, rainfall comes down. Anything that goes back up into the air, be it transpiration through plants or evaporation, that is considered green water. And anything that goes into the ground or runs to surface water bodies, that is considered blue water. We'll do a little bit more about that later. This is also conceptual. Every school kid knows the hydrological cycle, but this one's a little different because it looks at stores and flows quantitatively. This is data from the mid-90s. The italics show the flows and stores and are in regular print. For example, ice here. This is how much ice we're storing. Well, we all know that's changing because of water temperatures. We know that the rate of ocean evaporation is changing, and a few other things. But one thing I want to use this for is that the river basin is considered the standard for management, but we first think of water coming from a mountain or wherever, from a lake, and it comes downstream. And the big question initially is, who's going to get what water? Who's going to take the water? But there's another question, and this is more like the IWRM approach. Who's going to get the water? And this is a blue water perspective. This has nothing to do with agriculture. Even if you irrigate to agriculture, it's still blue water. It's water that you can develop and produce. The source to sea looks at, well, who's dirtying up this water as it comes down? Not only are you taking it, who's adding phosphorus and who's adding nitrogen and phosphorus, making algae blooms in the ocean, who's adding plastic, who's dumping raw sewage, what are the nitrogen loading, so on and so forth. So there's two views to take. One is pollution, and the other one is water as a resource. This industry dumping chemicals in, non-points pollution going in, so on and so forth. But it's a good model to look at constantly. When you change the land, you're changing the thermals above that land. Usually, like a marsh will have no thermals above it because anything with water in it is going to absorb a lot of heat and not cause the thermals. But I want to point out that warming does cause weather pattern changes, but so does land use change. And the latest data I saw in that, which I can't find the source, is land use change accounts for about 25% of weather pattern change. So it's not all warming, but it all works together. Okay. I did watch all of these videos earlier, and I'm trying not to repeat, but I'm also borrowing what they use. Karen Olson had a different depiction of how water was partitioned, and you've got the oceans here. And this little block comes out to be freshwater. This is all our freshwater right here, which what we're talking about. Well, if the glaciers are melting, well, that's going to go away eventually. If we're over pumping our groundwater, well, that's going to deplete. If we have permafrost that's not so permanent anymore, that is also going to work its way down to the oceans. But as of this moment, we've got a small, this is surface and atmospheric water. Surface waters are rivers and lakes and streams is just this small amount of all of the fresh water available. This is from the 2006 World Water Development Report. That's the main point I wanted to make about that. This also talks about how do you account for water? How do you keep track of it? And FAO makes a distinction between water counting, which is a quantitative assessment. It's sort of like the accountant versus the economist, where water auditing is more involved with social sciences, social and political economics. So they do make a distinction. And here, this slide has two things. FAO has a very detailed step-by-step monitoring methodology, and it really accounts for everything. It came about because of transnational boundaries to aquifers and watersheds. That diagram of the hydrological cycle that presumes everything's all in one location. As soon as you start adding the international dimension, it's a water basin on steroids. While we're talking with, who's got what, how much, so on and so forth, and we're making legal agreements, it forces the issue where there's going to be a very fine accounting system of water. Some of the data, which has been available for a long time, 1960, is Aquastat, which now uses satellite imagery, and that's at this site. So all the data you want is free, and you can get agricultural data from there. This is another way to show partitioning. It's just another type of diagram to show what goes where. You would apply this to a particular area. Falkenmark and Rockstrom are using it to distinguish between blue and green water. So we're back to that. Think of blue water as anything that runs off or something that goes into the groundwater. And this is something that we can extract, we can use it for industry, for irrigation if we want to, for drinking water, so on and so forth. But it is something that is developed. But the cycle for, and a lot of you probably know this already, the cycle for transpiration and evaporation is that this water comes to a decision point here. Some of it will go into the root zone, and it will actually breathe water and bring the nutrients up through transpiration. And going back again to Karen Olson had a presentation on regenerative agriculture. She stated this all a different way, where she said that we need to protect the root zone, where it had the farming methods had damaged the root zones. And so this kind of illustrates the importance of having those roots there. Especially if you don't have a lot of rain and you're in a dry area, which we'll get to in a second. Just another showing of green water and blue water, and the partitioning points, what's going to go into the ground. So if land use change will sometimes prevent water from going into the ground, you get a lot of runoff, which is not always good. There's a term called water harvesting, where the objective is to slow this runoff down, to either store it or make it go into the ground. So this is a decision point where, is it going to go into the ground or not? And then is it going to go to the root zone or not? Is it going to go into the groundwater? So on and so forth. All right. I believe this is from Rockstrom. I don't have it down here, but this is a global map of all the green water that's available. This is not water that mankind can extract and use for its own purposes. This is available towards resiliency for biomes, including agricultural green water where you're not using artificial irrigation. So there's a lot of it out there that we're not tapping into. And finally, this is a redo of the hydrological cycle. This is back in 2006, so it wasn't a secret. This was a World Water Development Report. And the reason why I say that is because this didn't make it into the current SDGs. And that's a criticism that Falkenmark makes in her articles. But anyway, I can skip a bit here. There's a lot you can be learned here. One of the things is, one thing we'll talk about is reuse. Water can be consumable and non-consumable. You're better off if you can reuse it multiple times. All right, here's another figure diagram for a place in Mexico, for Mexico City. And they've used the different colors to say like, okay, your rain comes down, and they partition off what's going to be used for rain-fed agriculture, for crops, livestock, and then when that runs out, how much of our blue water are we going to use from rivers and lakes, so on and so forth. Once you get down to cities and industries, drinking water, there's really not a lot of water we're using. It's mostly agriculture. All right, here's an application. This is different biomes in Africa. This is the tropical forest, if you will, at the equator. This is a desert. This is a desert. This is a different kind of forest. But this area is what we're interested in, because this is the savanna, which has a particular type. It's a particular type of biome which the air is very dry, and it just happens to be where the projected population growth is going to be at its greatest. So if we look at this again, this evaporation is going to go way up, going to be evaporating a lot of water, and this runoff is going to be very low. There isn't going to be any. Falkenmark compared, these are river basins. She's doing a water balance, and you'll get the semi-arid tropical savanna here, where you have the potential for a lot of evaporation. This is your runoff that you're going to get, and this is what was measured. I guess it's the actual evaporation, but it's very dry. You're only getting about 600 of rain, where in a humid tropical rainforest in Africa, you're getting 6 times that amount. And you've got a lot of evaporation, but you've got a lot of runoff too. So there's a lot of blue water. This runoff is blue water. A lot of blue water development is possible, but not in a semi-arid tropical savanna. Here you've got to, let's see. If I go back here, this rain is coming down, and this water vapor is going back up. There is no lateral movement. There's not much. There is a little bit of groundwater, In fact, that biome does have groundwater that's undeveloped, but it's mostly coming down as rain, being stored as much as it can be in the roots, and they're going right back out. Not much is going to rivers. Okay, this is a summary from her article. She said that for Africa to provide enough food, it's got to recognize that urban planning is a mega trend that even now, like half of the people in the world are living in cities. It's going to get bigger. So there's not enough planning for water for urban megacities. You need to use green water planning, as I was just mentioning. You've got to be able to use that. I put in this word regenerative agriculture. I don't think she used that word, but I'm putting, this is how we understand it from previous webinars where, in fact, Karen said it a lot simpler. She said, if we keep the roots good, you know, we're gonna have a healthier farm. This just goes into the science behind it. Rainwater harvesting. She said we'll have 3 times the yield if we do that. Supplemental irrigation. With climate change and weather pattern changes, where you could depend on rain before, you might have to have some supplemental irrigation. Rainwater harvesting is either putting it in cisterns or ponds, or even putting up barriers to force it to go into the groundwater. But these are adaptive measures that require some type of infrastructure. So that takes money, is what I'm getting at. We are having a shortage of water. We don't want to use the blue water globally. Virtual water and leapfrogging. Leapfrogging is using technologies without going through the development that the developed world already did. Example would be going straight to cell phones in a country instead of putting up a wired system in between. Or another leapfrogging example is going to renewable energies instead of using fossil fuel. Skip the part where we learned a lot of bad habits. Virtual water trade is acknowledging that some countries have lots of water to grow things. And some countries, if you're scarce of water, there's certain things you shouldn't be growing. And you don't want to grow rice in Saudi Arabia if you're taking groundwater that's in an aquifer that's not going to be regenerated. So you would import foods that have high water, so on and so forth. This will come up again later, but Falkenmark is saying that fertility management and middle-aged demographic management has to occur, which is very controversial. And when we're doing, we're talking about food, don't forget fisheries and aquaculture management. And that's a whole subtopic. She says at the beginning of her article that most blue water is channeled for transnational basins. So any runoff that goes off, you're not going to get that back for agriculture. I've seen examples of this, but it also has an implication that when countries are negotiating water, it puts pressure on where that water is going to come from, and it can feed back to agriculture. Where in Africa, in the current situation in that biome, the food production is not very good. Institutional responses, quickly here. There have been 3 water decades and 2 major water conferences, one in 1977 at Mar del Plata, and then there's another one coming up next March. That's the main message. 3 water decades, 2, a lot of detail, but you know, you can look at it on the slides I sent you. And this is just another representation of that. UN org is a coordinating organization mandated by the General Assembly, I believe, to coordinate all the different UN groups that were involved with water. There was a lot of duplication of effort, and these are all the links. You can go to this website, and there's a lot you can get from there. It's relatively young, so it's going through a learning curve, but a pretty quick one. If you look at the partners, and then there are NGO partners. In agriculture, you're going to be looking for IWMI, if I'm doing that right, SIGIAR for sure, FAO, and World Food Program. In other words, traditionally, you might get the global environmental assessment, I guess, from the UNEP. You're still getting it from them. It's just being channeled through a point of contact, which is the UN Water. But they do have a lot of information. They are concerned mostly with SDG 6, which is freshwater, and not so much for agriculture. That's why I say look for these NGOs and organizations when you're dealing with. Sometimes if you don't know what the program is, see who's involved, and it kind of tells you where they're coming from. But right now, there's an attempt to make it a concerted effort. Okay. These two articles disagree. The World Water Development Report came out in 2018 saying that nature-based solutions will be the answer. And a year later, Brady and Rosick said, nature-based solutions is too little too late. You need to slow population and economic growth. This is what Falkenmark was saying as well. Very controversial. Most population growth will be in Africa. 2/3 of the people will be in cities globally. And the three drivers are demand, and it's dramatic but unequal. Reduction of water resources. We talked about, for example, the polar regions are going to have less ice, so on and so forth. Where if people are looking for ice melts to provide their drinking water, there'll be a time when it's not there. Increasing water pollution. When water gets dirty, you can't use it. Current demands, 70% agriculture, mostly for irrigation, and global increase. Agriculture is going to increase by 60%. Energy 80%. So where all this water is coming from, I'm not sure. But and I'm not sure the projections are accurate. In fact, Brady and Rose, they'll say that this report is not accurate, but they're saying that they're too conservative. Earlier, one of the programs you had earlier, this is just saying that there's different types of water scarcity. There's physical water scarcity and economic, where you don't have the money to develop it. Notice this area of the savanna biome we talked about. There is groundwater here that could be developed, but that is also a supply side management mentality, where historically we just say, let's go get more, let's go get more. We've got to start looking at demand side management. Okay, getting into the SDGs. Let me see what we got here for. Okay. The first few SDGs have to do with water and health and controlling sickness. Historically, we started out with drinking water in the first water decade. Then for the MDGs, they included water and sanitation. Well, actually, early on it was water and sanitation, which eventually they realized as they started moving down that we're not taking care of pathogens that people were still getting sick. So water, sanitation, and hygiene, WASH, especially women and girls, Then that moved to wash at schools, plus hand washing programs, and wash at medical facilities, which is blood-borne pathogens included. They've been chasing the pathogens, but and there have been successes, but it still exists. Universal and equitable access. The SDGs, I'll point out here, talk about access, and for some reason, they're not looking at mortality rates, which is the ultimate goal. And for short-term goals, that's great to look at your access. But for long-term assessments, especially as things get tougher over the next century, we're going to want a longer-term metric. Open defecation is important because they're finding out if you provide drinking water. If you're not doing that, all you're doing is contaminating water. It's a vicious circle. Okay. Oops. And this is related, but it has more to do with people dumping raw sewage into rivers. And that is not only creating pathogens in the drinking water again, it's hurting the environment with nitrogen, phosphorus. Okay, WHO does have international water quality standards, but nobody can live up to them, so they're not enforced. Okay, this is not well known. I found it because I was actually researching it myself. But if you look at the MDGs, one of the indicators was the mortality rate of children under 5, but that was an indicator of overall poverty. It wasn't really looking at water itself. This graph here is population weighted water-related mortality rate, and it shows here that between 75 and this was the first water decade right here. Let's look at this line, which is an average of all of it combined. Water deaths, particularly per capita, have dropped a lot. And if you look at Africa, it has even dropped. However, if you look at this one, this is just absolute water-related mortality. And overall, it says it's still dropping, even when you negate the fact that population is getting much bigger. However, in the case of Africa, the population is outpacing the interventions. So per capita, Africa is still having less mortality per capita, but the number of deaths in Africa with population is still rising. So we shouldn't get too complacent. If you look at this, look at the red and the dark, these areas right here. This is the percentage of deaths attributed to inadequate wash. There are still, even though we've made good progress, there's still a lot of people dying from bad water or bad sanitation. Let's see, it's time. I'm going to skip this video, but I don't know, where are we? If there's time, I'm going to come back to this video. It shows the difference between typically land efficiency. We want more food per acre, and because of population and everything that's going on with in the world, all those pressures we saw, the hockey sticks, we're looking at water efficiency. We're looking at crop per drop, and that is measured officially in US dollars per volume of water. So how much food are we getting in money per amount of water? And that's changing too, because now we're adding the social and economic dimensions and saying, you can't just look at how much food are you getting per acre now. You've got to be efficient, say, how much value is your society getting, is your community getting for the water you're using? All right, this is a quick slide. It's just saying that water plants, water treatment plants, wastewater treatment plants, desalination, they all use energy. And because of that, they are producing greenhouse gases. So indicator 642 needs to incorporate the quantification of greenhouse gas emissions generated by water treatment systems. I believe this is a statement. I don't think it does that yet. But there is in the water, energy, food, ecosystem perspective, you've got to not just look at clean water, you've got to look at what are you doing to get it. And the whole idea of the nexus is you can't intervene in one of these components and not affect the others. In fact, often you make others worse unintentionally. This is quick. I'm going towards transboundary waters, but in case anybody doesn't know, you got the United Nations, the Economic Social Council, or ECOSOC, has 5 regions. The Economic Commission for Europe, United Nations Economic Commission for Europe, UNECE, is kind of a misnomer because it includes North America, Canada, and United States, and some parts of Asia. They address the environment, but they also address things that you would think is the environment: forestry and timber, land management, population, so on and so forth, sustainable energy. In the environment, they've got 5 conventions, 11 protocols. The biggest one that I want to talk about is transboundary waters. Transboundary waters was adopted by UNECE in '92, but jumping ahead, in 2016, it became the global system for transboundary watercourses in international lakes. The protocol is just it's just in the beginning, they forgot to add, what are we doing for water and sanitation and health? So they've added that. And they're just saying, who's got it? This has to do more with countries that share waters having institutions that are adaptive institutions. And so this proportion of transboundary with an operational arrangement, they're saying is there may not be a crisis now, but as time goes on, you're going to be wishing you had working institutions that was looking at that water source. They've got very interesting working groups. I represented the IEF on several of these online. The source to see I mentioned already, and they are including SDG 14, ocean ecosystems, and all of these considerations that link water to the ocean. And then I already talked about that, and water, agriculture, and climate change. These are all these proceedings are all available on recording. And somewhere in there, they've got SDG 6.6 is to look specifically at ecosystems. All right, so who's watching out for these? JMP is the joint monitoring program, which is UNICEF and WHO. Joint. Okay, here you go. Class, the global analysis assessment of sanitation and drinking water. You've got these people looking at the overall picture of cooperation and participation. And GEMI has more to do with, I would go towards the global compact of industry working for water. Coming up in March is the UN Water Conference. They're recognizing that you can't just look at water because water is related to many of the SDGs. So what they're doing is they're grouping SDGs into discussion, interactive dialogues. And if anyone's interested, there's an open webinar on 17, 18 January that you don't have to register for. Well, you don't have to be an accredited organization to get in. You can just go watch it. And this is a graphical representation of that. The theme is water for health, and it will go down and like goal 17 is partnerships, all the ones I just talked about. What I find interesting is water for development is what includes agriculture for zero hunger. So agriculture is I see it in many places is considered an economic activity and not necessarily a health issue. So on and so forth. Okay. Faith-based principles and approaches. I'm sorry, we're running, well, we started late, so faith-based principle approaches. I'll jump to this. When we're looking at these transnational agreements and also UN agreements, I hear the word normative a lot. It's what we should be doing, but that's also code for it's not binding. They're setting a global standard of this is what the global social norms should be. Now you can take that home and you can ratify it and make it law, but we're all agreeing this is what everybody should be doing. And that's my take on how to explain that. But the fact is, some of it is what is a commitment? And many times the word commitment is in the context of commit money, commit funding. And this 2023 water conference coming up, that's a goal that they're saying we know what to do, we need the funding. So that's kind of what's behind all this. And if we look at the 3 water decades, governments paid for the first decade and they learned lessons from that, both in how to control the money and where it didn't go, where it was supposed to go, but also it was very expensive. So the second decade was more towards the market. The third decade, which we're in the middle of right now, maybe a blend of both, but it seems to me like the institutions are asking for governmental support. International development at the beginning, known as the elimination of underdevelopment. Elimination of the underdeveloped was started in 1949. Great acceleration started around 1950. So, not being naive, this development is based on a business model. Everything's not free. It's a good thing, but it's not free. And it's if your country donates money to development, your country's contractors get dibs at providing those services. So that's the reality. I guess it'd be naive to think that this is all charity. It's not. Let's see. Sometimes for very low income countries, some projects are granted and not loaned. This week there was a workshop at UNECE for the source to sea, and one of the sessions was about financing, and they did make that clarification that some places are granted. Okay, we've known about limits to growth since 1992. It's not a secret. I'm interested in what they just put out recently. Arthur posted this on LinkedIn. I was doing a paper on this last year for my degree, and I was interested in trust and the perceived rate of progress and how that relates to commitment by stakeholders, by people who would be involved in dialogue. Okay, and these next 3 quotes are actually from a cluster meeting I went to yesterday, and it has to do, and I used at that meeting the parallelism or the metaphor of water, which is highly contextual, which you have to, if you're going to take action, you have to figure out what your actions are going to be. The purpose for which mortal men have from utter nothingness stepped into the realm of being is that they may work for the betterment of the world and live together in concord and harmony. Now we must not look at our own ability and capacity, nay, rather we must behold the favors and bounties of God in these days, who has made the drop to find the expression of the sea, and the atom the importance of the sun. water is a complex issue. I know there's a lot of slides here. I'm really just hitting the surface. You can go deep on any of these, but it doesn't matter. This one's a little longer, but it's very appropriate. It is necessary to appreciate the difference that is made by the conditions in a cluster or in parts of a cluster and by the characteristics of a people. That is, by the reality of circumstances. Accordingly, the ways in which the society building power of the faith will find expression in different settings will vary. But the challenge facing the friends serving at the grassroots is essentially the same in every place. They must be able to read their own reality and ask, what in light of the possibilities and requirements at hand would be fitting objectives to pursue in the coming cycle or series of cycles. As the friends ponder what is before them, they will readily see that for every community, there is a goal in reach, and for every goal, a path to reach it. Okay, this, I should have paused a little there, sorry. On the IEF website, Arthur has a short course on discourse. It was the same intent I was using today, was to try to provide a toolbox for discourse on water topics, getting into that right zone and the right context and then making sense of it. Arthur's put a I think this is from a summer high school that he conducted. Winnie has a couple of books on with lots of quotes regarding water and agriculture, mostly agriculture, but I think the two are kind of closely linked. Here are two quotes from the agriculture. When the science of medicine reaches perfection, treatment will be given by foods, aliments, fragrant fruits and vegetables, and by various waters, hot and cold and temperature. So the supreme happiness of an animal is to have the possession of a green and fertile meadow, perfectly pure flowing water, and a lovely verdant forest. If these things are provided for it, no greater prosperity can be imagined. Okay, and here's a compilation at the IEF website again, and a couple of quotes from water. My meaning is this, that in every aspect of life, purity and holiness, cleanliness and refinement, exalt the human condition and further the development of man's inner reality. The purport is that physical cleanliness doth also exert its effect upon the human soul. The water for these trees is the living water of the sacred words uttered by the beloved of the world. In one instant are such trees planted, and in the next their branches shall, through the outpourings of the showers of divine mercy, have reached the skies. A dried up tree, however, hath never been nor will be worthy of any mention. And could I have a volunteer to read this one?
My God, my adored one, my King, my desire, what tongue can voice my thanks to thee? I was heedless, thou didst awaken me. I had turned back from thee, thou didst graciously aid me to turn towards thee. I was as one dead, thou didst quicken me with the water of life. I was withered, thou didst revive me with the heavenly stream of thine utterance, which hath flowed forth from the pen of the All-Merciful. O divine providence, all existence is begotten by thy bounty. Deprive it not of the waters of thy generosity, neither do thou withhold it from the ocean of thy mercy. I beseech thee to aid and assist me at all times and under all conditions, and seek from the heaven of thy grace thine ancient favor. Thou art in truth the Lord of bounty and the sovereign of the kingdom of eternity.
Thank you.
Thank you. Thank you so much, Mark. You've given us so much to think about. Thank goodness you put your slideshow. That is your slideshow, right? That's in the
It
chat.
is.
Do you
It
think
is.
you could put it in there again? Maybe just copy and paste it again for people who may have joined us
Right.
later.
Yeah. Were there any questions in the chat?
I don't know that we had a whole lot of discussion in the chat itself. I think people are just waiting now. There was it was you're quite rich with information. So maybe I think we'll just start now. Anyone have any questions? If you could raise your hand, please. Any thoughts? Quanta.
Thank you. I was wondering if there is any data available where the individual, the household use versus the industrial use, and also, are there any efforts? I just thought about it when I was watching the slides, that rainwater retention. Is there a mechanism where the water resources are, for instance, in the southwestern United States, the water is in agricultural use is being deprived because of, for instance, Las Vegas uses water, and water that is not really being used for really meeting human needs. Is there sort of kind of detailed data available? I was curious.
Yes, but I think you want more than that. Couple of questions there. Industrial and household data. Well, your question, again, we have to go to context. We're talking the United States, we're talking a developed country. We're talking a place that does have data. Under the US EPA and channel down to states, all of your water suppliers are required to keep detailed records and give you annual reports on those records. It used to be called a consumer confidence report, but now, but it is available. They'll tell you volumes, but they'll also tell you what their sources are, what threats exist to your sources, and also they'll test the quality of your water to see what kind of impurities are in there or not, especially biological pathogens, which shouldn't be there, but also there's US EPA has developed a whole set of and a time schedule for what to sample for in terms of quality. In terms of okay, going to the rainwater, I mentioned rainwater harvesting a little, but I couldn't go into it too deeply. And I spoke to a developing world context where I said that if we're in the savanna of Africa, anytime you have water runoff, if you can slow that water runoff, you could either put it into cisterns, you could collect it from roofs, and you could save it, or you can save it in a dirt pond that won't stay there a long time, or you can save it in a dirt pond that you really want to go into the groundwater. So those are the different kinds of rainwater. In the context of the United States, a lot of people will take their rainwater from their roofs and put it in the rain barrels for irrigation. But when you get into Las Vegas, these are not just technical problems, these are social economic. I did do a little reading on that on the Colorado River recently. And some of the debates have to be something like, why can't we fill up our swimming pools? And so there's this imbalance of consumerisms. You know, what are your rights? What are your are you living within the rights versus living within the limits of the environmental limits, so on and so forth. So the Colorado River is a dire situation, and it's rainwater would help a little bit for your personal needs, but the biggest thing is socioeconomic and political. There is water there, but it's not really being used wisely in many cases, and that comes under the political economy.
Thank you. Roy?
Sure. Thanks so much, Mark. A couple of disconnected questions. One is, you talked a lot about the big water cycle, but the small water cycle that people are talking about is, from terrestrial land that goes up and then down, never reaches the ocean, is increasingly seen as important, especially in the context of regenerative agriculture. And can you increase that small, the smaller water cycle and basically enable landscapes to create their own rain? And I'm curious, what's the latest thinking, the latest research on that? And then the second is, I've heard some people say, the water crisis is, the water issue is in fact also an energy issue. I mean, if energy was free, you could just desalinate. And at what point in time, how cheap does energy have to get to really start mitigating some of these things? And I'm, that's speculative, but curious how that's informing or part of the debate, because more and more places are desalinating, but it's expensive and energy intensive, but that's also changing with technology. So two disconnected questions, but I love your thoughts on that.
You're talking about water, everything's connected, I think.
Yeah.
Let me share again. Okay, in the interest of time, I went over this quickly, but can you see that?
Yeah.
Okay. This is a desalination plant. It may as well be a water treatment plant or a wastewater treatment plant, or it may be both. You may we're trying to recycle. Sometimes you've got a wastewater treatment plant that feeds into a drinking water treatment plant, or you're recycling the water, treating it, and either using it for irrigation or whatever. But water reuse is a big deal. Now, on this graph, let's see, I'm glad I wrote your question down. Let me get the first one. The first one, I showed that, I don't have to go back to it, but local land use is a huge deal. In fact, you can't talk about water resources without talking about land. The two are linked. Not only does land use change local weather, which it does, but it will change entire landscapes. There's a river in the Great Ruaha River in Tanzania. It's a perfect example of what could go wrong. You've got a great river, but at the headworks, they cut down all the trees. Right after the headworks, they put in rice farms that are have a lot of water evaporation that weren't there before. Both the mountain where the headworks are and the rice fields are close to each other, so they're both changing local weather patterns. The rice fields are not maintained well, so right at the beginning of the river, you're losing a lot of water. that kind of irrigation brings another problem too, where it raises the water table and sometimes it'll bring up salts. So now you need funding just to drain what you've already dumped. And that's part of the reason why I wanted to go to that video, which I might, because it shows very efficient drip irrigation where you're not causing a lot of these problems. But the water goes downstream, goes to the Serengeti Plain, and now for the first time in a long time, the last 20, 30 years, during the summer, the river actually goes dry. Now you've got wild animals looking for water, and now they're migrating to populated areas. They're getting killed because they're in populated areas. And if you think things aren't bad, you go downstream, there's 3 hydropower dams. So there's a tributary off the Great Ruaha River, which is the Little Ruaha River, where some of you may know that name, which is the Ruaha Secondary School. It's a high school for girls. I was there late 1990s, the needs for the hydroelectric plant are so big that they're telling farmers you can't use blue water for irrigation. You can't use our water that we're extracting that has available for us for your crops. One of the dams is just the whole water, but you know it's that whole thing where you're trying to keep water, energy, food, and ecosystems. Oh yeah, you're killing ecosystems on this river too. And you're changing land use, so you're changing the weather patterns. Now, this example is not a bad one in terms of it's all within one country. If this were happening on a transnational basis, you'd have people screaming across the table both ways, and it would be difficult to come to consensus. So that's the first one. The second one here is on the slide. And desalination considerations. It's high energy use. There's 16,000 desalination plants in 177 countries. It's widespread. Some countries listed here, 100% of the water comes from desalination. There are problems with it. It's like when you take the drinking water out, you have to throw away the salt water, which now you're adding salinization to local ocean water, which is not good for the ecosystem. Brine management's needed. Okay, somebody asked me this question once on a radio talk show in South Africa. They said, "What about desalinization?" My response was, "If we could only have fusion." And it is a big energy consumption. And you look at the top of this, as long as we're using as long as we're using fossil fuels, coal, etc., we're actually producing greenhouse gases in a vicious circle to the point where we've got to use desalinization, which is high tech. It's expensive. It's high technology. One thing I didn't mention for developing countries in terms of energy is historically, before we had these expensive treatment plants for drinking water, turn of the 20th century in this country, we had slow sand filtration, which it takes up a lot of real estate. So real estate developers in cities don't like it a lot. And it's also labor intensive. So a lot of people don't like it because it's labor intensive, but it uses no chemicals, and it's a very simple machine, but it provides drinking water. As water quality standards went up, they couldn't meet them in the US. But in fact, Lawrence, Massachusetts, I used to work at the water treatment plant. I used to manage the water treatment plant where it was the first one in the country to have slow sand filtration. It has what the Germans described as a Schmutzdeck, which is a biological film. It mimics soil, where if water goes, that's why groundwater is supposedly good enough to drink, because there are no pathogens in the water, unless there's some pollution introduced to it, which a lot of the things we're doing today are possible. But when rain hits the ground, there's bacteria in the soil that eat the pathogens, and or the pathogens that might be on the surface. And as it goes down, the bacteria will start starving because there's no food left. And that's how slow sand works. And there's also, once it goes through, the water comes through, all the bacteria have been eaten. All the viruses, etc., have been eaten by the bacteria in the soil, if you keep the soil healthy. And then you've got groundwater that has no light and no nutrients, so it can't grow pathogens. And so the slow sand filtration, which would be good for developing countries, you don't need energy. It'd be good for the world. And they still have them in the US. But like I said, it's labor intensive and it takes up a lot of space, so it's not always a good option. It's also, it's still somewhat expensive to build, but cheap to operate. And the technology to operate them is easy. So there's been some research in the 20th century and developing worlds to go back to slow sand filtration. That's what I was trying to do in the 90s, but it turns out that in the early 2000s, MIT went there and did that. But it turns out also that they were trying to redevelop it too. They had more resources than I did. But if you go back all the way to the first, to the 1980s, the first water decade, slow sand filtration was introduced there. And I should mention, I didn't say it in the presentation. One thing that I find, in terms of progress and trust, etc. If you look at the 1977 Mar del Plata, Argentina report, and you compare that to modern reports, it was all there. Just like in the limits to growth on the Club of Rome, they were saying in 1972, we have environmental limits. Well, there's a counterpart to that. The 1977 report had everything we needed today. They even mentioned climate. So the concepts have been there a long time. It's just a matter of making it happen. So I think I kind of answered your question, Roy, did I?
Yes, thank you.
All right, let me stop share.
Yes, thank you.
Okay, thank you. Next, Winnie?
Yeah, I'm feeling extremely naive, but very much resource rich now from your presentation, Mark. My naive question is, what about the growing of a green belt around the deserts, which St. Barb Baker was interested in, and I did think was going on. And how does that affect availability of water as the water table rises for the world itself? We can't make more water. Is that correct? Or can we make more water? And is that greenbelt thing still working? And also, how much of an aquifer is there under the desert? I understood there might be some. And I'm talking about Africa.
Okay, the green belt in Africa, that's what you're talking about? That's where
Yeah.
I have, just as an exercise to make a point, I have to pinpoint the, you'll see this all the time, you have to pinpoint the context. We're talking in Africa, we're talking future building of a green belt, correct?
I'm also thinking that there was one underway on the edge of the desert.
I know.
Am I wrong?
Saudi Arabia is planning a long city, if you will, but that's an enclosed greenhouse, if you will, a real one. When you ask your question, I'm thinking, if you look at that map of if you image that map of the biomes of Africa, you will see the equatorial area is like a green belt. It would be nice if that could be expanded. Now, groundwater in a desert might exist on two levels. And again, it depends on the area. I see that. One is like in Saudi Arabia, they have water aquifers, but they're not being replenished, meaning they're mining ancient water. At once it's gone, it's gone. And if going back to the three plates, if you will, where I said, you had the ocean, then you had freshwater, then you had surface water. The big loser here is when everything makes its way to the ocean, and now you've got to go to desalination or something like that. In other words, if in the future we lose our ice storage, that was the relevance of that chart with the storage versus the rates, because the rates are changing and the storage locations are changing. So the whole game of the water cycle is changing. And so how do you adapt? And part of the, let's see, I want to back up a little. A green belt. Can you tell me more about what you mean by that?
Well, I understood that there was the idea, and I thought it had been underway at some point, that in North Africa, there was an attempt to grow trees on the edge of the desert to restore.
Expand the ecosystem.
Yeah.
This is what I thought. Yeah, that's possible. And again, it's a self-building thing. Where are you going to get the water from? Is it renewable? Here might be a good application for water that was in a drinking water system that went to a wastewater treatment plant, that people don't want to drink that water, even if you treat it, but it can be used for agriculture. So you might get effluent from a wastewater treatment plant for agriculture, but that's a complex question, because until you pinpoint it down a little bit. But for a specific area, is it possible to expand the ecosystem? I think so. You've got to have a renewable source of water, and you've got to what you're aiming for is the long-term changing of local climate.
Yes.
Which is hard.
Okay.
Dawn, did you have a clue on who's next?
Yes, Linda Gershuni is next. Yes, we just have a few more minutes. We've kind of gone over already, but we'll answer. We have Linda, and then we have Janet, and then we have Purya. We'll finish with Purya.
Okay, I'll try to be brief. I was so impressed. Thank you for such a wonderful presentation, especially for a person not trained in that background to have access to so much research and present it so clearly and beautifully. I was wondering, with respect to access to knowledge and also participation in generating it, from my very different background of 40 years in Haiti, I was just so astounded by of course, through Baha'i activities and the power of consultation and learning to read our reality, but in the wider community also, when communities have access, even graphically, to research and the chance to go through a participatory process, there is such a capacity for change and applying it to their lives and gradually learning, and even children through education. So I was wondering if there is, I'm sure there are many, many things happening in the world, but I'll just give in contrast an experience that fell out of the sky to me, to be involved in a huge project, to me huge, in Democratic Republic of Congo, where $130 million had been spent already on a wash project. And in 3,400 villages had received a banner saying, Village Assaini, clean village. And then they discovered through the first evaluation that they couldn't document any change in the water quality and even the goal of protecting, especially infant mortality. And so I happened to get hired out of the blue completely to do community development. But when I got there, basically the African responsible people said, "Oh, this is great, give us more, let's go and talk to people and involve them and so on. It was a year-long process, but the non-European staff said to me, no, 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 people are superstitious. They don't believe really in hygiene. Excuse me for even saying such a thing, but that's what I was told. And we want you to train the trainers. They'll train the facilitators who'll go tell people what to do. So it was so astounding to me, this immense capacity of people, which we know is there. Gradually, there was a kind of opening to that kind of thing, even which was specifically what I was asked to do. And when the director said, actually, we were like a huge ship trying to turn a little bit. So from my completely non-technical background, I'm just wondering of how people are being involved more through education and participatory learning and action.
Very context. Again, there are a lot of success stories, and this is a place where Baha'is could do social economic development projects, and it could be lots of, in fact, this series has already shown several great case studies where this has happened. My feeling from attending WASH conferences over the last couple of years is that the WASH community is somewhat frustrated because, and this is my reason for saying, why are you focusing on access where you're not giving it to them, you're asking them to pay for it, and they don't necessarily want it for that. They don't necessarily want to pay you for a connection. So, and you're focusing on connections like that's going to work. Well, what if there's migrations from climate or something, or a disaster? Well, all of these water access points assume that you're living somewhere. Well, if that changes, your water's gone too, or your wash is gone. That's again, that's why I would focus on the results of clean water, as in less sickness. Let's see. Like I said, lots of successes. Those graphs I showed you where the mortality rate has fallen a lot. However, the following slide said, well, there's still a lot of people where 2 out of 10 who die are dying from water issues. So there's still a problem. And like I said, that's what I was going to say, is there was a survey taken of water users in a developing country. I think it was Africa. And for those people who had connected water, they were really happy. I said, well, what are you happy about? He says, well, one, we don't have to, they don't mind carrying water. They don't want to wait in line once they get there. But when they're in their house with water, first of all, the contexts are starting to change where, you know, if you have this image of a grass hut with people carrying a bucket of water on their head, that's changing. It's not so far away from what we've got here when they do have connected water. And also the bar has been getting raised. It's like, do you have water? Well, do you have one water well in a village? Oh, okay, you got water. Well, now they've changed it to, well, do you have piped water into your house? So the standards have been rising over these projects. But I was surprised that, one, they don't have to go, it's safer. They don't have to leave the house. It is safer. But in terms of hand washing, they weren't so, they were seeing the convenience of it and the safety of it. They like the walk to get the water, but they don't like waiting in line. That was all convenient. But they seem to be missing the pathogen part where this is healthy. But like I said, they've come a long way. They've got a long way to go. I sense frustration in the WASH community. I'm not sure why, but I do sense it.
Okay, thank you. Purya is next.
Hi, thank you for the very good, great presentation. My question is about artificial aquifer recharge, that it is they talk about it sometimes very much. My question is how much is it feasible to recharge the aquifers in areas that had lost a lot of underground water, and what are its impacts?
What are you? Again, every place is different, but you said you described what you're talking about. If someone is taking too much water from the aquifer, it won't be able to regenerate. You can help it regenerate by capturing rainwater and putting it on the ground and holding it until the water goes down. But that's not going to be as effective as rain, as good rain. Again, land use, the way your land is going to determine if your water is going to run away, if it's going to run down the hill, or if it's going to stay long enough to go into the soil. And we've changed a lot of our land to where water, rainwater cannot percolate into the ground. So land use is a consideration. Rainwater harvesting, you can't, the savanna example was natural. That's the rain they always get. So the question is, can you hold any runoff there is? Can you keep the roots healthy so it keeps the water? Can you hold the runoff that's there and make it go into the ground? That's a different situation. But the biggest problem is, and this ties into some of the early questions where, Winnie, we can't make water, but we can manage what we've got better. We can keep it from getting dirty. We can keep it from running to the ocean to where we have to use desalination plants. So can we, all water goes to the ocean eventually, or it goes to the atmosphere. There are different ways of harvesting water. You can harvest fog. You can, but that's in small drinking water qualities. We didn't really talk about the non-conventional water sources. We kind of did, but we didn't talk about it under that heading. Desalination is one. Rainwater harvesting is another. Fog capture is you put these plates up and the fog attaches and drips down. But if we look at the water cycle as a conceptual model, can we take care of our land? Can we take care of our root system? Can we keep that water from running off to the ocean unless we have enough of it? If we have enough of it, we want it to run to the ocean. We want it to go to a river so that it can be used there and keep the ecosystem happy but it's always a fine. It's very much it's no different than, as an example, the fishing situation that we had a long time ago and now, where if you've got fish that are growing in the sea, there's only so many you can capture before you start taking too many. Well, the same thing for water. There's a normal cycle. In fact, if you remember the three leaves that looked like there were three water basins, where I was showing the difference between, they're called water balance diagrams, because in fact, it's probably worth looking at. Sorry. Oops, there it is. Okay, these were three different river basin systems, and this I don't know if you can see it, but the title is water balance. Every This could be an island, if you will, but it's like we're all sharing the same water. We're all in the same bathtub, you know, so we all drink from the same water source, but you got a temperate forest over here, and there's that amount of rain, and then you've got a humid tropical forest. There's a lot of rain. So with a lot of rain, you still got a lot of evaporation, but this is how much you got going to the sea. This is how much in a savanna, this is how much you've got going to the sea, and it's probably groundwater. And this is what's going to the sea. The question is, every place you go to, first of all, you manage it by the river basin and all the people that are in it, but then you've got to keep everything in balance. So this right here is probably groundwater coming from the aquifer. If you take too much, you're going to be out of balance. And that's kind of what's going on right now. All the dialogue, it could be stated that way, is to say, you know, how do we put things back in balance?
Yeah. Thank you, Mark.
Let me get out of that.
Oh, our last question here, Wanjiku.
Yes, you talked, Mark, you talked about commitment, and I wanted to see how the commitment as fast as will, because I think like it's not a matter of not having funding, is the will. And also in that, looking at the complexity versus simplicity, you know, there goes to what Linda was talking about, right? You also read about the reality, reading at the reality on the ground. And it looks like, you know, people don't get the opportunity to read the reality, their own reality. So when the projects are brought, they're too complex and it really doesn't make any meaning. So I'm really trying to see how can we use the Baha'i community building as a means of really simplifying all this complexity, which has helped so many communities behind and they can move forward. And also knowing, as we keep saying, like, you know, the solution is the writings of Baha'u'llah. That's the how all this problem is going to be solved. And I'm really happy that you brought those quotations at the end. So all this is really like, it could be simplified, knowing as, you know, just to summarize what I just said is simplified, let people do their reality, and you came in like knowing this is what they want, but not coming to tell them this is what you want.
Excellent question. Thank you for it, and also for reminding me something I didn't say. This was that graph where I said that, and thank you for remembering those quotations, because those are very appropriate from a Baha'i perspective of, we have to look at our own circumstances, we have to decide what it is we can do, and then we have to have the will to do it. Remember all those hockey stick curves I showed you? Population, water use, everything was the hockey stick. This should look like a hockey stick, but this is a success story of political will, where in the case of drinking water, we did not follow the hockey stick, which means if we have the political will in other areas, we can do it there too. We're not, for example, energy and economic development. Those are two coupled variables that form the hockey stick. Well, if we do it right, this is a perfect case example that I don't have to show it to you any longer, but this should look like a hockey stick. And that's what's the success story about it is, in the Wash area, we did have commitment, we did have political will, we did not live to that hockey stick. We don't have, as population goes up, we don't have more people dying. We actually have less people dying from bad water. So we have an opportunity to make change. And I'm not sure if you were asking about the commitment, the United Nations commitment they're looking for. They're looking for funding in March, and I'm not sure how that's going to come out. But yeah, the commitment can mean a lot of different things, and it gets to the difference between what is normative, what's the norm for the world, what's a Baha'i law, what's a you know, what's just a good, what kind of local commitment can we do, what kind of global commitment, so on and so forth. Did that answer your question? I'm not sorry. I'm not sure.
Yeah, well, yeah, I just really like however much money is put out there, if the locals are not involved, I think the success will be less. And actually, I'm just really would have wanted to give my example, because I grew up in an area of Kenya where by the time I was young, we had running water. And until I went to the Baha'i World Center and I came and traveled in western part of Kenya, I've never seen a dead child. If you bring your child home, they survived. We had running water from 1971. And you could see the impact of that, you know, and it was the food for, I mean, what people, the money was brought, but the people did the work. So I think the real solution is really getting the people involved, you know, but not really just thinking these are helpless people who need to be helped, and really using the Baha'i principle of community building. That's my outlook.
It is true that I didn't mention it, but water is directly linked to economic development. No water, no economic development. No, and then no economic development, no water. So they are coupled. I mean, that's a good coupling.
Oh, thank you. Well, friends, this has been a wonderful discussion. We want to thank you, Mark, for coming and speaking to us today. Wonderful, wonderful information.
Thanks, Trinity.
Yes, wonderful. Thank you so much. And thank you all for attending. We'll be looking forward to see you next month, the end of January. We'll be having Dan Perel speak. All right, thank you.
Thank you, Mark.
Thank you.
Thanks, everybody.
Thanks, Mark.
Thank you.
Hey, Gary, we were talking about you. Your ears burning?
Well, we had an NSA meeting. I was in a meeting all day and I got a little bit lost. So that's why I came on a little late.
Glad you can be with us